All right. If we're balancing redox reactions with basic solutions, the good news is it's very, very similar to acidic solutions. In fact, you go all the way through step 4 just the same as you did acidic solutions. However, when you're done with step 4, recall in step 4 you add water to one side to balance out the oxygens, H plus on the other side to balance out hydrogens. You still do that, but at the end you then add OH minus hydroxide to both sides to cancel out the H pluses that you've added. That's how we're going to do it. We're just going to add the same amount of hydroxide to both sides to cancel out any H pluses we added. Because H plus is acidic, we need to cancel it out to make water with hydroxide and get a basic solution. All right. Sounds more complicated than it is. So let's go through an example. Here is MnO4 minus plus I minus goes to MnO2 plus I2. Pretty easy to separate into half reactions. We got I minus and I2, so I minus goes to I2. MnO4 minus goes to MnO2. No problems there. Okay, note we need to balance it. We've got 2 iodines here and 1 iodine here. Balance the 2 half reactions, so we need a 2I minus. 2I minus goes to I2. Note, we've got 1 manganese, so it's fine. We're about to go to step 4 and balance the oxygens. All right. We notice we've got 4 oxygens on the left side, 2 oxygens on the right side. We balance it with water. We need to add 2 more H2Os. So that's what we do, add 2 more H2Os. Note the iodine reaction is okay. We don't have to add water or anything. So we need to concentrate on this one. We added 2 H2Os to the product side of this reaction here, which gave us 4 hydrogens, and so we have to go to the other side and add 4 H plus. Since we added 4 hydrogens on this side, we need to add 4 H plus to the left side. So note, we've got this balanced now. 4 H pluses on this, 4 hydrogens on this side, 4 on this side, 4 oxygens, 1, 2, 3, 4 oxygens, 1 manganese, 1 manganese. We are balanced. The problem is we are balanced and we've got H plus around, which means our solution is acidic. Since we have 4 H pluses here, we need to add 4 hydroxides to both sides. We've got to neutralize these 4 protons with 4 hydroxides, but since we're already balanced, if we've added 4 hydroxides over here, we have to add 4 hydroxides over here to maintain balance of atoms. So I'm going to add 4 hydroxides to the left side and 4 hydroxides to the right side. Note, 4 OH minus plus 4 H plus makes 4 waters, and that's what's always going to happen. However many extra H pluses you add, you're going to convert them into waters by adding the same amount of hydroxide. I had 4 extra H pluses here, so I'm going to add 4 OH minuses to make 4 waters, and I still have my 4 OH minuses over here, so now I've got water. Permanganate goes to manganese 4 oxide plus water plus 4 OH minus, and I'm in basic solution. And then wait a minute, you're like, wait a minute. 4 waters, permanganate, manganese dioxide, 2 waters, 4 hydroxides. I've got waters on both sides. Well, if I got 4 water over here and 2 water molecules over here, well, those 2 of these will cancel out 2 of these, so I'm left with 2 water molecules on the reactant side plus permanganate goes to MnO2 plus 4 OH minus. I've got 2 of the same thing, waters on both sides in equal amounts. 2 waters here, 4 over here. Cancel 2 of these, that will cancel 2 of these. I'm left with 2 waters on this side. And my iodine reaction is still just going fine because I didn't have to add any water or hydrogens to get it balanced. However, now it's time to use the electrons. I've got a 2 minus on this side, neutral on this side. Note, if I add electrons to this side, this would be 4 minus in neutral, so I can't do that. I have to add 2 electrons to the product side to make the reactant side 2 minus and the product side 2 minus. All right. Note with this reaction, I've got, what do I've got here? Okay, I've got 1 minus on this side and 4 negatives from the hydroxides on this side. So can you see that we need to add 3 electrons to the reactant side of the permanganate reaction? We need 3 electrons over here. So 3 minus plus 1 minus will give us our 4 minuses. So we do that, 3 electrons on this side. And note, 2 electrons here, 3 electrons here to cancel them out. I have to multiply this step by 3, this half reaction by 2. So I get, okay, 6 I minuses goes to 3 I2s plus 6 electrons. 6 electrons plus 4 waters plus 2 permanganates goes to 2 MnO2s plus 8 hydroxides. Whew, electrons cancel. Nothing else cancels. So here I go. Here's adding everything up. 4 waters plus 6 iodides plus 2 permanganates goes to 3 I2 molecules plus 2 manganese 4 oxides plus 8 OH. And that's balanced. Yeah, lots of fun here, okay? Acidic solution tends to be a bit easier. A basic solution tends to be more fun because, yay, I can cancel stuff out. You tend to be able to cancel more stuff out using basic solution because you're adding waters and there could be more waters on the other sides. So that makes basic more fun, but, a bit more difficult. So there's plenty of time to practice these, but just for grins, let's go through one, shall we? Let's give it a practice. So we can work this out. Balance in acidic solution, this reaction. Okay. Well, this looks pretty easy. Can we see our 2 half reactions? Well, the first one has got to be Fe2 plus goes to Fe3 plus. And the other one is Cr2O72 minus goes to Cr3 plus. Now, I wrote down a lot of extra stuff, rewrote down stuff when I'm working through the problem so you can see what's going on. But when you're doing a problem like we are here, it's easiest not to have to rewrite a whole bunch of stuff. So what I'm going to do is say, okay, I've got my half reactions. I need to balance everything other than oxygen and hydrogen. Okay, iron's balanced 1 to 1. Ooh, I got 2 chromiums here, only 1 on this side, so I need to put a 2 in front there. Okay, no problem. What's next? Well, I got to balance oxygens with H2O. Okay, so don't have to worry about this reaction. Note, I've got 7 oxygens on this side, which means I need to add 7 water molecules to the other side. All right, I have to add 7 water molecules, so now I've got 7 oxygens, but here is 14 hydrogens. 7 times 2 is 14, none over here, so I need to add 14 H pluses onto this side. All right. Phew, so far so good. Iron is good. All right. Now what? Well, everything's balanced. My hydrogens and oxygens are balanced. Just for sure, 7 oxygens, 2 chromiums, 14 hydrogens, 14 H plus. Got it. So now it's the charges. Okay, we go up here. I got 2 plus and 3 plus up here. The only thing I can add is electrons, negative charge. So I see that I have to add electrons to this side, 1 electron to the product side, so that I've got 3 plus and 1 minus. That makes 2 plus, which I have over here. Man, what do I have down here? Good heavens. Okay, I've got 3 plus. No, there's 2 of them. I've got 6 positive charges on this side. So I've got 2 chromium 3 pluses, means 6 positive charges. I've got 14 pluses and a 2 minus, which means that's 12 positive on this side. If I have 12 positive on this side and 6 positive on this side, and the only thing I can add are electrons, what must we do? Well, you're right. I have to add electrons to this side because it has more positive charge, and I need to add 6 electrons to there. All right. Because 6 negative plus these 12 plus 14 positive plus 2 negative makes a total of 6 positive, and that's what I have over here. Can anything cancel out? Well, oh, nothing yet, but note I've got 6 electrons here and 1 over here. Can we see that I need to multiply this top reaction by 6? Well, that's not a problem. Put a 6 here, a 6 here, and just change that 1 to a 6. Cheating. All right, but okay, now I've got 6 electrons, 6 electrons. I can add these two up. My electrons cancel, and what do I have here? I have 14H plus Cr2O72 minus plus 6Fe2 plus goes to 6Fe3 plus 2Cr3 plus 7H2O. There we have it. Okay. Looks good. Does that make sense? Everything is balanced. Everything looks good. Yeah. Note that when we did the oxidation state, note this iron here. Iron goes from +2 to +3. So iron goes from the +2 to the +3 oxidation state, so it loses 1 electron. What's the oxidation state of this chromium? Well, we have 7 oxygens, so that's -14 here. And we have to have a net 2 minus, so what if each chromium was +6, 2 of them would be +12. I'm sorry, if each chromium was +6, 2 of them would be +12. +12 and -14 gives us our overall 2 minus charge. So each chromium was +6, and it went to +3. The chromium went to +6 to +3. But since I had 2 of them, each chromium lost 3 electrons, but since there's 2 of them, that means 6 electrons were lost. Or no, 6 electrons had to have been gained. Yeah, 6 electrons had to have been gained. And there's my 6 electrons. 6 irons had to lose electrons because they only lost 1, but each chromium took in 3 electrons. And there's 2 of them, so with the total of 6 electrons taken in. Yeah, so this works out nicely. But note, I didn't need to really worry about the oxidation states. I just had to balance the atoms, balance the charges, and then it all came out and with the proper stoichiometry this way. Okay, so we learned about oxidation states and whatnot in Gen Chem 1, and now we are learning to balance redox reactions in Gen Chem 2 because they're a little bit trickier. And now that we've done that, finally we can start moving on to electrochemical cells.